Hi, welcome to another session of Circuits and Networks. In today's class 18 under two ports networks, we are going to see the shortcut method to solve the impedance, admittance, or any other network parameters. So we'll start with the first problem. Here you can see the problem number one. We need to find out the impedance. This is also known as Z parameters. So the network is shown over here, which has 4, 3, 7 ohms respectively, and the standard notation for Z parameters is given by V1 and V2 in terms of Z parameters and the current which is flowing through these Z parameters. So it's a standard equation derived from the Ohm's law. Now when you see this network, it's a simple T network. Now if at all we consider T network which is having the parameters like ZA, ZB and ZC, then we are going to get the value of Z parameters as ZA plus ZB, then the middle parameter as ZB, ZB, and the other parameter as ZB plus ZC. How we got this? Just we need to open circuit these two ports and take the sum of these two, ZA, ZB, that becomes Z11. Then ZB, ZB, that is nothing but the intermediate between this port 1 and port 2, that is shared by ZB in common. That's why the ZB, ZB comes into the picture. And then you try to open circuit this port 1, then you will be left over with ZB and ZC. The sum becomes ZB plus ZC. Now for this particular example, if at all we consider the formula, then the impedance will be equal to 11, 7, 7 and 10 ohms. Now if at all we need to find out the impedance parameters for this particular network, you can see here we have 2 here, 5 here, and we don't have any other parameter here. Then how to solve this one? Simply apply this formula. You will get Z is equal to the sum of these two is 2 plus 5, that is 7, and 5 is intermediate between port 1 and port 2. Then this Z12 and Z21 value will be the same, and when you open circuit this port 1, you will be left out with only 5 ohms. So that is how this answer goes like this. Similar case, if at all we need to find out the impedance parameters for this network which is shown with P ohms and Q ohms, you tell me the answer. It will be directly P and P plus Q ohms. I hope you understood this shortcut. Now let us find out the admittance parameters for the same network. So we know that the Z is equal to 11, 7, 7 and 10. Now Y parameters can be obtained in terms of Z parameters with this standard formula. So we need to find out delta Z. So delta Z is nothing but this Z22 Z11 multiplied with Z22 minus this Z12 and Z21. So this answer becomes 61 ohms. Now with this you can get the value of admittance parameters, which is equal to 10 by 61 minus 7 by 61 minus 7 by 61 and 11 by 61 Mohs. Now if the same problem they are interested to obtain the ABCD parameters, which is also known as transmission line parameters, or if at all we need to find out hybrid parameters, then how to solve this? We know the answer. Z is equal to this 11, 7, 7 and 10. Now ABCD parameters in terms of Z parameters are given by this formula. Just to substitute the formula of these parameters, and we are going to get the value of ABCD parameters as 11 by 7, 61 by 7, 1 by 7 and 10 by 7. And when you are interested to obtain the H parameters, this is a standard formula of H parameters in terms of Z parameters. Then you can easily get the value of H parameters, which is nothing but 61 by 10, 7 by 10, minus 1 by 10 and 1 by 10. So this is a shortcut method. You can check out with our previous videos how to derive this shortcut methods. Just remember these shortcut methods. It will be easy for you to prepare for your competitive exams. Now the next question, which is very interesting here, we need to find out the admittance parameters, and the network is shown in the type of pi, where you have YA, YB and YC. So how to solve this? So the standard notation for admittance parameters are given by this equation. Now I'll short circuit this port 1 dash, and the source will be V2 supplying the current I2. Once this is shorted, the YA parameters, it is shorted by a line, then it goes off. Then we have YB parallel to YC. The equation for this equivalent will be YC YB by YC plus YB. And if at all I want to know the value of voltage in terms of current, the answer is YC YB by YC plus YB I2, and this we are treating as equation 1. Then Y22 is equal to I2 by V2 from this standard equation. So you can get the value of Y22 as 1 by YC plus 1 by YB. Now if at all I want to know the value of current I1, this I1 is a current. this I1 current is quite opposite to this I2. So from the current division rule, I can get the formula as minus I2. I2 is acting as total current. The opposite to this YB is YC. So that's why YC is over here. And the sum of these two, it becomes YC plus YB. And this we're treating as equation 2. And now from equation 1, what I'm trying to do, I'm framing equation 3. That is, I'm taking I2 in terms of V2. Then equation 3 substitute in equation 2. Then we are going to get I1 is equal to minus. This I2 value is minus V2 times of YC plus YB by YC YB times YC whole divided by YC plus YB. Now this YC plus YB, it goes off. And here you can see YC it cancels. And we are going to get the value of Y21 as I1 by V2 equal to minus 1 by YB. Now when the port 1 is short circuited, we got the values, which is nothing but Y11 and Y21. Now on similar basis, we are going to do for this port 22 dash, we are going to short it. Then we are going to get the value of Y1 in terms of I1, which is given by equation 4. Then Y11 will be equal to 1 by YA plus 1 by YB. Similarly, I'm taking a current division rule to get the value of I2 over here. So this I2 is opposite to I1. That's why minus I1 YA by YA plus YB. Equation 5 is framed. Now from equation 4, we can get the value of, sorry, this is not I2, this is I1. This is a correction you should make. It's the I1 in terms of V1. Now you can get the value of I2 here by substituting the value of I1. It's a mistake over here. You please correct over here. So this I1 when it is substituted over here, we are going to get the value of Y21, which is equal to minus 1 by B. Thereby, when this port 2 is shorted, we are going to get these two parameters. Now we have Y11 and we have Y21 and Y21 and Y22. With this, we are going to get the value of Y parameters, which is obtained to be 1 by YC plus 1 by YB minus 1 by YB minus 1 by YB 1 by YA plus 1 by YB. Now let us use this formula to get the solution for this particular pi network. Though this pi network you can easily solve with this standard formula. Wherever you have this YC YB, just replace with the values of the resistors given in the ohms. So the value will be 16 by 3 minus 10 by 3 minus 10 by 3 25 by 3. So this is how you can have a shortcut for network parameters. You try to solve this particular network, which we have already sorted out in our previous videos. Go and check those videos and check the answer whether you got the impedance parameters as 4, 3, 3 and 3.5 ohms. Now that's all for today's class. I hope you like this video. Please share among your friends, subscribe to this channel and press the bell icon for the future notifications. Thank you.